All right, so now we move on to special angles and exact values part 2, aka lesson 2.2 part 2. And in this lesson, we're going to take all of what we learned in last lesson, which is this idea that there's exact values, which can be representative of some sort of x and y value on this sort of unit circle that we've created of radius 1. And then what we want to do is extend that now to saying, well, what are the possible different areas or what are the possible different solutions given that we have a certain domain in this situation? So that's what we're going to talk about today is, again, we're using that unit circle we've constructed and developed, and then we kind of know what's going on within each of the different quadrants and where to look for certain angles. But now we want to figure out how do we establish the different values based on different domains. Okay, to do what we're going to look at today, we're going to break it into 3 simple steps, and those 3 steps are the following. First of all, we want to determine the quadrant's angle by just looking at the sine ratio. So whatever the ratio is, whether it be positive or negative, depending on what primary trig ratio it is, it's going to tell us the location to look for. The other part we want to consider is that domain. So we want to make sure that it's within the domain that they're specifically requesting. Step number 2, determine the reference angle. And remember, this will always be a positive angle. It's always going to be between 0 and 90. And then we want to just like roughly sketch where this location would be, what quadrant, and then what that reference angle looks like to help us figure it out. Now, to solve for that reference angle, we're going to basically take the inverse ratio of either sine, cos, or tan, and we want to take the exact value of whatever they give us so that we can figure out what is that answer in terms of it being in quadrant 1, and then we can kind of, based on that answer, put it into the different quadrants, and you'll see what I mean very shortly. Last thing we want to do is determine the rotation angles given that reference angle and the appropriate quadrants that it would lie in based on whether it's positive or negative and what type of ratio we're dealing with. Now, obviously all of that just kind of sounds like words to you at this point because you need to see an example of how this works. So let's go down to example 1 where we see sine theta is equal to 1/2 and we want to solve for the appropriate theta such that it's in this domain. Now, when they say this domain of 0 to 360, that's just essentially saying if we do a full circle, where is it that sine theta is equal to 1/2 as an exact value? Now, again, this is symbolic of the y value in terms of the y value of the coordinate in which it lies in the unit circle. And we want to draw right now just a very quick sketch of what this thing looks like. So what I would reference, or what I would do right away, is just create a basic Cartesian plane. And we want to consider where sine is positive because 1/2, or the given ratio, is positive. Now, sine is positive in these 2 locations. It is positive in quadrant 1, so we're going to draw a terminal arm in quadrant 1. It's also positive in quadrant 2, because by the cast rule, we say it's all in the quadrant 1 and s in quadrant 2. So here's our 2 possible values. Now, here's what we want to solve for in terms of the angles. We want to solve for the little one in here, and then we want to solve for the bigger one, which I'm going to outline in orange there. So as long as we have those 2 thetas, then those are going to be where sine theta is equal to the exact value above 1/2. Now, to start this, we're going to go to step 1, and we want to figure out, okay, what quadrant's it in? Great, we know that it's going to be in 1 and 2. So I'm just going to list that as 1, and I'm going to list this one over here as 2. This is where it's positive. Step number 2, we want to figure out what the reference angle is. So I'm going to take this and go, well, theta is equal to the inverse of sine of that ratio of 1/2. And when we type this into our calculator, make sure it's in degree mode. You're going to go shift and then the button, if you have the Casio, or second and then sine. And we're going to type in the fraction of 1/2. Close that bracket. Whoops, let's make sure that's right. Close the bracket here. Enter. We end up getting that it's 30 degrees. So that's going to be equal to the reference angle, or the angle that it would be in quadrant number 1. Now, so we have one answer, 30 degrees right here. But because this is also equal to our reference angle, which we could go theta r is equal to the theta we just found, that also means that 30 degrees is over here. So the broader angle that makes up the orange angle is actually equal to 180 minus 30. So here's our 2 solutions. We have one answer, which is theta is equal to 30 degrees. The other answer for theta is going to be, and I'll just list it right below here, we have to do a little bit of math maybe below the triangle here to get this orange theta that we're going to be looking for right here. And I'm going to make that a touch neater because I want to make sure this is as good as possible. The orange theta is calculated by taking 180 and subtracting away the reference angle. Now, what is this equal to? Theta is equal to 180 minus the 30 degrees, which is the reference angle, and therefore the other theta we're looking for is 150 degrees. So the 2 solutions are 30 degrees and 150 degrees, where sine theta is equal to 1/2. That's how we would summarize that answer there. Okay, so let's apply this same thing to our next problem. They want us to look at where tan is positive, or where tan theta equals positive 2.5. 2.5, we want to write this as a fraction, right? I think it's better to have it in the fraction form. Not actually, that's debatable. We could write it in fraction form or not. It would be either way. We want to write this on a domain of 0 to 360. So again, we're considering the full unit circle in this situation. I'm going to draw my basic Cartesian, and I'm going to think about, where is tan positive? Well, it's definitely positive in quadrant 1, so we're going to write our terminal arm in quadrant 1, but it's also positive down in quadrant 3. So let's label that here. We're going to go quadrant number 1, quadrant number 3, 1, 2, 3. There we go, and I always hate when my Roman numerals are a little bit messy there, so 1, 2, 3. Perfect. Okay, the first angle we want to find is the one that is contained in red here. So that's our first theta. Our second theta, which we're going to outline in orange, is if we rotate all the way around from the positive x-axis over. Now, to figure out this first angle, we're just going to take this and go theta is equal to tan inverse of 2.5. And because it's already positive, we don't need to worry about writing the absolute. Theta is equal to, let's make sure we type this into the calculator, second tan, or shift tan, 2.5, close the bracket, and let's just make sure, because I can actually go back and press the bracket, enter, and I end up getting that this is 68.19, or to the nearest degree, that this is 68 degrees. Now, this is also, again, equal to our reference angle, because that's referring to it being in quadrant 1. So we have 68 degrees, which is here. That's going to be our first solution. To get the second solution, if we also know that down here is 68 degrees, to get the full rotation that is the one in orange, or our theta that's in orange, we're going to go theta is equal to 180 plus the reference angle that we've just uncovered. That means it's theta is equal to 180 degrees plus 68 degrees. And then just to make sure we don't make any errors, we should always go to our calculator. Whoops, don't want to swipe over too much on the page. We're going to go 180 plus our 68, and we should get 248. Awesome, we do. And so therefore 248 is the answer. And we want to summarize this and go, our thetas, or possible answers, are 68 degrees and 248 degrees. And this is where tan would be equal to positive 2.5 as a ratio. Okay. Now, I know originally on surface value, that might seem a little bit confusing as we're kind of breaking into this lesson, but we'll continue through, and then you'll see through some repetition that, oh, okay, these aren't actually too bad. All right, let's go down to this one. Now, we see cos as an exact value of -3/2. And again, if we knew this like the back of our hands, in terms of if we know the unit circle and we sketch out the unit circle, and we can just easily answer that from that, no problem. But here's how we're going to solve this. On a domain of 0 to 360 degrees, aka a full circle, if I draw out my Cartesian plane, so I'm going to draw out my x and y, cos is negative in which quadrants? It's negative in quadrant 2, and it's also negative in quadrant 3. Because in quadrant 1, they're all equal to a positive value. In quadrant number 4, cos is positive, so we want it where cos is negative, which is in quadrant 2 and quadrant 3. Now, let's outline which degrees we actually want to solve for here. The first one is outlined in red. The second degree is outlined in orange. So in order to figure out the one in red here, first of all, we got to figure out what the reference angle is. So to do that, we're going to go theta is equal to, we take the inverse of cos, and then put it to the absolute value of 3/2, again, because we want to figure out what the reference angle is, right? If we want to figure out the reference angle, just make that thing positive. So to do this, we then go theta is equal to, and in our calculators, we go second cos, we set up a fraction, and we go second the √3/2, arrow over, close the bracket. We end up getting that this is 30 degrees. And again, if you knew your unit circle very well, you would know this is √3/2, because that's the x value at that 30 degrees. Now from here, we don't have any angles yet. We just have our reference angle. So I'd always recommend you go theta r attached to this one. To figure out these two angles, well, we know that 30 degrees is nested right here. 30 degrees is also nested right here. So in order to figure out the red angle, and then afterwards figure out the orange angle, we're going to need to do the following two calculations. Let's start with the red angle. Red angle is equal to, we take 180 degrees and we subtract away our reference angle. Now that's going to give us theta is equal to 180 minus our 30-degree reference angle, and our first angle that we've uncovered is 150 degrees. So cos is equal to this negative 3 over 2 when it's 150 degrees. Again, when you get really comfortable with the unit circle, you'll be like, oh, okay, I can find that angle pretty easy. Now for our second one, we're going to go theta is equal to, we want to take 180 degrees, but instead of subtracting, we're going to add the reference angle. In this situation, theta is going to be equal to 180 plus our reference angle of 30 degrees. And we end up getting our second theta is equal to 210 degrees. Awesome. So now we can summarize this in a solution. Maybe I'll just move up all of these answers here so that we can create a bit of a gap at the bottom and summarize our solutions. So there's all the thetas. Awesome. From here, what we can do is we can say, therefore, theta is equal to the following two solutions. We have 150 degrees, and we also have 210 degrees. And this is the solution for when cos is equal to negative 3 over 2, or negative root 3 over 2 as an exact value. Awesome. Okay, let's go on to our sine example. In sine, we see that this is a negative value. So right away, when it's between 0 and 360, we want to sketch out where sine is negative. Definitely not quadrant 1 because they're all positive there. Sine is going to be negative in the tan quadrant and the C quadrant, aka the cos quadrant. Now, to get our value, again, what we want to be thinking about is these are the two ones we're looking for. We're looking for this angle, which is the first theta, and then our second theta, which is going to be the one in orange. And I don't want to make it that messy, so I'm going to try to wrap over like this. I don't know if that's going to be any neater, but we'll do it. There we go. So that's our bigger angle. Now, when we solve for our reference angle, remember, we're going to make it positive. So we're going to go theta is equal to sine inverse of the ratio of positive 0.36 because we're solving for the reference angle. Theta is equal to, in our calculators, we go second sine 0.36 as a positive, enter. This is going to give us 21 degrees to the nearest angle, which will be our reference angle. And now on our triangle, we can sketch this in and say, well, 21 degrees is here, 21 degrees is here, because it's always between your terminal arm and the x-axis. And so now, if we know that this is quadrant 3, and this is quadrant 4, or quadrant IV in Roman numerals, then in order to figure out our two solutions, let's do these here. Theta is equal to, the first one is going to be 180 plus the reference angle, which is 21 degrees. This is going to give us a total angle of, red theta is equal to 201 degrees. Okay, for our orange degree, we're going to go orange is equal to, we have to take 360 degrees, which is a full rotation, and subtract away the 21 degrees. When we take 360 and minus 21, well, 360 minus 20 is going to be 340, and then minus another 1 is 339. So our orange angle is therefore going to be equal to 349. Not 349, 339, my apologies. There we go. And then we just want to summarize our solutions and say, therefore, theta, when sine is equal to this negative 0.36 as a ratio, is equal to 201 degrees, and it's equal to 339 degrees. Done. There's our solutions. Awesome. So again, always draw out a picture to help you determine where these terminal arms are or what the possibilities are. And then just be very careful with your domain, right? Because your domain might not always be a full circle. Maybe it's only between like 0 and 180, or maybe it's between 0 and negative 180. Like they might play around with this domain, especially as you go into diploma questions, or diploma type courses and questions. So be very careful with that there. All right, now let's go into this example here. Again, we're on 0 to 360, so I'm going to draw up my Cartesian plane. Where tan is positive, the quadrants where tan are positive is quadrant 3 and quadrant 1. So we're going to sketch that in there. Now, the two possible angles we want to consider are the following. We have one here, which is going to be our red theta, and then we have one here, which is the rotation into our third quadrant. And maybe I'll just move that theta so that it's kind of over here, so it's not in the way. Okay. Now, in this situation, we know that it's quadrant 3, which is here, quadrant 1, which is up here, not quadrant 2. To solve for our reference angle, we're going to take the inverse and go theta is equal to tan inverse of 1. That means that theta is equal to, we bring out our calculator, go second tan and 1. This gives us 45, to no surprise, because when tan was 1 from our previous lesson, it was 45. So that's our reference angle that we're going to write down. Now, if that's our reference angle, it's actually also equal to the red angle. So this is equal to theta r, which is equal to 45. Now, if this is a 45-degree angle, it means that anywhere where we have a reference angle is also 45. So to get the orange one, we're going to have to take 180 and add 45. And when we add 45, we're going to get an angle of 225. So this is going to be 225, which is the secondary angle. And now what we want to do is summarize it and go theta is equal to, first of all, 45 degrees, and then second of all, 225 degrees. And this is for when tan is equal to +1 as an exact value. Okay, let's go over to this one. We're adding a layer of complexity, and that complexity is simply what happens when the sine theta or whatever primary trig ratio isn't just isolated for the exact value. Well, we just have to do that little bit of algebra to start the question. So I'm going to write this as 2 sine of theta is equal to -√3 like this. Then we're going to divide both sides by 2. And as we can see here, we're going to get sine theta is equal to -√3 over 2. Now, we want to sketch this out because we're like, okay, where is sine equal to a negative value? If we drew out our Cartesian plane here, sine is negative in the following quadrants. It's negative in the tan quadrant and the cos quadrant. And I'm just going to sketch that out just a little bit better there. There we go. Now, there's 2 possible angles here. First angle is here, which is our red theta. And then our orange one is going to be where we rotate all the way around and get this value here. Now, again, we want to figure out what the reference angle is first and foremost. So I'm going to go theta is equal to sine inverse of the ratio they gave us, but make sure it's the absolute value or the positive one, because we're just going to solve for it where it's in quadrant 1, aka the reference angle. We go second sine. I set up my fraction, √3 over 2. And I want to make sure I enter that correct. Good. This ends up giving us 60 degrees, which is the new reference angle for this problem. Then I go down below here and I'm like, well, if this is 60 and this is 60, then it actually gives us a lot of power to figure these out. The red angle is equal to 180 plus 60. And I'll do these all in the same line just because of the space. 180 plus 60, which is equal to, maybe we don't have enough space. Actually, I'll just shift it over. That's how I'll accommodate for this space. So we'll move this one here. 180 plus 60, this is going to be equal to 240 degrees. Perfect. And then in terms of our in terms of our orange angle, this one is going to be 360 minus 60 degrees, which is then equal to 300 degrees. And I'm going to try and write this as neat as possible because I can see that space is kind of limited here. So this is equal to 360 degrees minus 60, which is equal to 300 degrees. Perfect. So then if we summarize our solution below, we're going to say theta is equal to, for this exact value here, we have 240 degrees and we have 300 degrees. Now, for some of you, you might be like, oh, wait a minute, this step of that we've been doing where we write it in black below and we highlight it, isn't that just redundant? Yeah, a little bit. I mean, if you wanted to just highlight your solutions earlier here and you just get 240 and 300 and you highlight these two, great, no problem. I'll see that as the same thing. That's totally fine with me. Okay, let's go over to something like this one. Well, sine theta equals 0. If we want to solve for the exact value of this one, again, we're like, where is sine equal to 0? And on the unit circle, we got to be thinking, okay, the y value, where is the y value 0? I sketched that out on the graph here. The y value is equal to 0 when it's along the x-axis. So we have this angle or this angle, and without even doing any sort of math around this, we're like, okay, this occurs at 0 degrees. This occurs at 180 degrees. So if I had a point on either end, aka a point here and a point on this side, then those occur where it is the following. We have a cos value of 1 and a sine value of 0. We have a cos value of -1 and a sine value of 0. So that the region in which this happens between 0 and 360 is where theta is equal to, first and foremost, 0, and the second value is 180. Now, let's just double check our domain, because is 0 included? It is. That is very important to check, because if on the diploma or a future question it just said greater than, then 0 wouldn't be a solution. Or if it said, oh, it's only up to 180 but not including 180, then we would have to be like, nope. But in this situation, both of them work. We're happy with that. Okay, let's go over to this one. Again, another one where you have to do a little bit of algebra with this. So what I'm going to do is take this and be like, well, cos squared theta is equal to, I add the 3 over 4 to the other side. When I take the square root of both sides, because it's a cos squared function, I want to square root both sides, giving me the individual cos theta, which is equal to the root 3 over 2, because I can individually square root 3 and 4. Now what I want to do is draw this out and be like, where is cos positive? If I drew this using some axis points, cos is going to be positive in quadrant 4. It's also positive in quadrant 1, where they're all positive. And so I'm going to write quadrant 1 and quadrant 4, just so we can keep track of the numbers here. And then the two angles that I'm going to be looking for, the first one is going to be the red angle here, which is actually just the reference angle. And then the other angle is going to be where I rotate around and I get this as theta. Okay, now let's solve for our reference angle. To get the reference angle, we go theta is equal to cos inverse of the ratio we found, but make sure it's the absolute value version. This ends up giving us a theta, which is equal to, in our calculators, we're going to go second cos, we're going to create a fraction, take the positive version of 3 over 2. This ends up giving us 30 degrees, and that's the reference angle in the first quadrant. Really good thing about this, though, is that if this is 30 degrees and this is 30 degrees, then one of our angles is actually solved for already. We know that the red angle, which is equal to our reference angle, is 30. The other angle that we're going to be looking for is the orange angle, which means we take 360, a full circle. We subtract away the reference, which is 30, and this is going to end up giving us a theta value. And actually, I'm going to try and condense it all together here, just like we did in the previous problem. We're going to move this one over like this. And then I'm even going to add this detail. This is equal to the reference. And then our angle down here is going to be 330 degrees. Perfect. Okay. So as a summary of our solutions, just because I think it's important just to make sure it's clear, we end up getting that we have 30 degrees and 330 degrees, where that is equal to positive 3 over 2. And again, the more and more you get comfortable with this unit circle, you're going to become a pro at this. You'll be like, oh, by the time you get to the 30 level, unit circle will be nothing to you. You'll be sketching this out blindfolded. Okay. Now, solving for exact sine, cos, or tangent values given certain ratios. So what they're going to do here is they're going to give us a mixture of ratios here, and this is going to help us solve this in the following way. They say if tan is negative and cos is negative, then what is the exact value of sine theta? To do this, we're thinking, okay, well, if I draw out a picture, where is cos and tan both negative? It's actually negative in quadrant 2. This is the location where only sine is positive and the other two ratios are negative. Now, the information this gives us is that we know that cos and tan represent some sort of values in terms of this triangle. So when we talk about tan, it's going to be negative 2 over 3. Tan is the opposite over the adjacent. And when we look at this one, we're like the opposite value, which is on the opposite side of the triangle, is going to be a positive 2 because it's upwards. The negative 3 is going to be associated with the x's because x's are on the left-hand side. Now, what does the cos value help us out with? It says the adjacent over the hypotenuse. This part here is the hypotenuse. So what we want to do is we want to then go to this and be like, this is square root of 13, not 1 and something, square root of 13. Now we have the full triangle. In order to figure out what the sine ratio is at this, all we're going to do is be like, well, if theta is represented in here as the reference angle, then what we do to figure out sine is we say, therefore, sine theta is equal to the opposite, which is positive 2, over the hypotenuse, which is root 13. Unfortunately, we don't like it where it doesn't have a rationalized denominator, so we're going to go back to unit 5 and rationalize this using root 13 over root 13. This ends up giving us that the sine theta is equal to 2 square root of 13 divided by 13. And again, if 13 is a prime number, we can't really do anything with this other than just to say, hey, you know what, this is the solution, we're done. Okay, so use these two ratios they give you in combination to figure out that alternative trig ratio that they're looking for, or the exact value. And again, should this make sense that it is positive? Yes, because it's quadrant 2, and in quadrant 2, the only ratio that's positive is the sine value. Okay, part B. If sine A is equal to negative 1/4 and tan A is negative, express cos A as an exact value. Again, these ones are really nice because you're like, okay, I'm going to draw out my Cartesian plane, and then I'm going to be like, where is sine negative and where is tan negative? Because we want where both of them are negative. They're both negative when the cos value is positive, and that occurs in quadrant 4 here. So we're going to have to figure out, based on this, there's some sort of, whoa, I don't want to shift that around. There is some sort of x value, and there is some sort of y value that when they come together, they give me this terminal arm. Well, sine is represented by, if this interior angle is the reference angle, sine is opposite over hypotenuse. And we know the hypotenuse is always going to remain positive. So my hypotenuse is going to be the positive 4. My negative is going to go with the downwards direction. It's going to go with the thing that we know the y value is down. So it must be the negative component because our hypotenuse will never get associated as that. Now we are missing one value here, and that's the adjacent value. All they told us that was tan was negative here. And if tan is negative here, that's good because it tells us what quadrant to look in, but it doesn't tell us anything about that adjacent. We need to solve for this x value here. So let's use some Pythag here. We're going to say that 4 squared is equal to 1 squared plus the x squared, or that value we're looking for. Now 4 squared is 16, which is equal to 1 plus x squared. We see this as x squared is equal to 15. And when I take the square root of both sides, because I want to isolate for x, I square root, I'm going to get that x is equal to plus or minus the root of 15. Now, in this situation, the value that's appropriate is positive root 15 because we're on the right-hand side of the x-axis. I guess you could say that, or we're on the right-hand side of the y-axis if you want to say that. So probably a better way to say that this is positive. Now, in terms of determining the cos value as a positive value or as an exact value, not as a positive value, we write this as cos of that angle, which we don't know what that angle is equal to the adjacent, which is 15, or square root of 15, divided by the hypotenuse, which is 4. There's our value that we're looking for, as cos A has some sort of angle, but its exact value at that angle is root 15 over 4. All right, here's where one last detail before I tell you to work on your practice. It would just be to label these quadrants. So to be like, oh, okay, this is quadrant number 4, and that's where cos is positive. And then if I go back up here to this example, we said where sine was positive, and sine was positive in quadrant 2, or aka where tan and cos are both negative, just so that you have a little bit of an indication of like where we're getting this info from, or what quadrant we're in when we're discussing these things. The other detail you could always add to these before you get to your homework, you could always throw the cast rule over top of these. So if it helps, let's say you were doing that over here. You could write it as the following: C, A, S, and then T, just so that you know that you're looking for a specific quadrant where they're both negative. That occurs where sine is positive. And then down here, you could do the same thing and be like C, A, S, and T. And you know that sine and tan are both negative in quadrant 4. So if this helps you and that's a way of like kind of guiding your overall approach, use it because it is definitely designated to help you discover this in an easier way. All right, good luck on your practice. Let me know if you need help.